In this video, we're going to take a look at esters. Not this ester, and not this ester either. Well, the esters we're going to be looking at are organic compounds. These are derivatives of carboxylic acids. And the basic structure of an ester is we have a carbon connected to a carbonyl group, or carbonyl group here, connected to an oxygen, and then more carbons. And so this is like a carboxylic acid in that we start out with this structure here, a carboxylic acid. Okay, we're starting out with a carboxylic acid, and we're going to react this with an alcohol. An alcohol, we might recognize the alcohol as having the OH or the hydroxyl group here, which is different than this. This looks like an alcohol, but it's part of a carboxylic acid. Carboxylic acid and a alcohol. Okay, now to make this reaction happen, we're going to have it in an acidic environment like this. And what will end up happening is we're going to take the OH off of one of these and the hydrogen off of the other. And you might recognize this here as being water. So this is what we call a dehydration synthesis. We're going to remove water and join two molecules together. And these two molecules, a carboxylic acid and an alcohol, removing water, is going to give us an ester and water. Here we have an interesting molecule called salicylic acid. And you might recognize parts of this molecule in that we have an aromatic benzene ring, we have an alcohol group coming off like this, and we also have a carboxylic acid group coming off of there. Now, if we just covered up this part right here, you might recognize this as phenol, okay? And if we just cover this part up right here, you might recognize this right here as benzoate, or benzoic acid, benzoic acid. All right, now, we're going to take this molecule and we're going to do two different possible reactions with this. The first reaction is we're going to take this part right here, the alcohol portion of the molecule, and we'll combine it with a carboxylic acid. In this case, we're going to use vinegar or acetic acid. So here, I'm going to take my acetic acid, like this, okay, and then carbon, double bond O like this, and then here, a CH3. Here is my acetic acid. And we're going to do here a dehydration synthesis. We're going to take the OH from here and the hydrogen from here, remove water, and combine these two molecules together. And so what does that look like? Well, we're going to, here it's going to require acidic conditions. And we're going to take our molecule here, our salicylic acid, and it's going to look like this. I'm drawing a little bit smaller here because I'm running out of space. And we're going to take our salicylic acid here, carboxyl group, OH like this. And then down here, we're going to remove water, okay, and combine our acetic acid here, like this, and then like this, and then CH3. Okay, now, what we did here is we made an ester. Remember, an ester is this carbonyl group here, combined or attached to an oxygen and then to another carbon. Okay, now this is just backwards, or reversed from what we saw just a little bit before. Now this reaction is kind of interesting in that here, this is salicylic acid. Maybe you've heard of this, maybe you haven't, but salicylic acid is a molecule that's found naturally in the meadowsweet plant. It's also found naturally in the willow bark of a tree, and it is a mild analgesic. That is to say that it is a pain reducer. It is also a fever reducer. And what what the history on this is there was this chemist in Germany, and his father had arthritis, and his father was taking this salicylic acid, and it was causing him stomach bleeds, but it helped the arthritis. And so the son, who was a chemist, is like, well, I want to help my dad, and I want to help his arthritis, but these stomach bleeds this could kill him. So he thought, well, I'm going to try combining it with acetic acid, and that is vinegar. And so the fancy term for this is he acetylated it, okay? And he created this new molecule like this that had the properties of treating the arthritis, the mild pain reliever here, but it also reduced the inflammation or the irritation of the stomach. Now, his employer was this company, this German company, you may have heard of it, it's called the Bayer Corporation. And salicylic acid has a name, or let me say a source, and that is it comes from the meadowsweet plant, and the Latin name for this is Spirea, S-P-I-R-A-E-A, Spirea, O-M-A-R-I-A, Almeria, okay? Spirea almeria. And when they combined salicylic acid and acetic acid like this and formed an ester, they took the names here and they combined them together, and it became A from acetic, and spirea, it became aspirin. And this is where we get the molecule aspirin from, okay? Now this is the active ingredient in aspirin, but it hurts the stomach. And so if you acetylate it and you turn it into this, aspirin, if you make aspirin, it's a little bit easier on the stomach. Now, that's one direction we could take the salicylic acid. There's another direction we could take with this, and that is we could combine it with an alcohol. So up here, this is a carboxylic acid group, and if we combine it with an alcohol, like say methanol, wood alcohol, okay, so methanol, okay, this is methanol. Methanol or wood alcohol is the common name. If we combine these two together here, now we can see here's our carboxylic acid, here's our alcohol group, and we've used the same acidic conditions like this, and we would combine these together and form another ester. And so this time we would have our benzene ring like this, okay, and then this stays here, H, like this here, and then C double bond O, and then now we're going to combine on here our methyl group, our oxygen and CH3 like this, and it forms an ester. And this molecule here now looks very similar to aspirin, okay, except what we've done here is we've combined up here instead of down here, all right, and this has a fancy name here. This is called oil of wintergreen. We create oil of wintergreen. And oil of wintergreen is a molecule that's put in topical analgesics. That is to say, you might take this molecule, it smells like wintergreen, kind of has a minty or a spearmint smell to it. And if you rub it on your skin, then this molecule gets into your skin, and what happens in your skin is it actually breaks down back into salicylic acid, which has a mild pain-relieving analgesic effect, which is just kind of interesting. So one other curious side note on all of this acetylation, taking acetic acid and combining it with a molecule like this and creating an ester. So there's another molecule that has an interesting structure, and that is morphine. And so here is the structure of morphine. And morphine is a very strong analgesic. It's a pain reliever, and it's also it's rather addictive. And so there's actually these chemists in Germany, they saw that morphine is a nice pain reliever, but it's kind of addictive. And so they thought, well, what if we tried combining acetic acid with morphine, just like we did with salicylic acid, and see what we come up with. And they came up with acetylated morphine that was actually much stronger than morphine. And they thought, oh, this is amazing stuff. Because it's so much stronger than morphine, you don't need to use as much of it. You can use a smaller dose. And they thought if you use a smaller dose, it would be less addictive. Well, they called this new amazing morphine, this acetylated morphine, they called it Hero N, because it was like a hero drug. And in English, people started calling this heroin. And heroin is just acetylated morphine. You're just combining acetic acid or vinegar and morphine. And you make heroin. And it turned out that heroin was much more addictive than morphine. And it's kind of funny to think, I guess, that the Bayer Corporation back in the day was selling heroin to people. And that's not something they like to advertise too much today. Now, if you ever go through the airport and you see these drug-sniffing dogs, or if you have a drug-sniffing dog come through your school, the dogs are not trained to smell the drugs themselves. That's not how they're trained. They're trained to actually smell acetic acid. And it's the acetic acid that is used to make the drugs. But you see, it's the vinegar, or it's the acetic acid that the dogs are trained to smell. All right. Now you know just enough chemistry to be dangerous. All right.